Hey guys, BBI here. I want to stop and say thanks for tuning in and checking out whatever the video is about that's about ready to come up next. If you could take a minute and hit subscribe, I'd greatly appreciate it. And if you enjoy what you've seen here, make sure to hit the like button. We'd greatly appreciate your support. Anyhow guys, all that aside, let's get on with the show. Oh man, oh my. Look, I got no room over here. I've got to get hustled up on a couple of these things. So we're going to start moving a little bit quicker. It takes a monumental amount of time to be able to do each one of these videos. It's a lot of time. A lot of time. So I hope you all appreciate it. What we've got here is an X-Force, or not X-Force. I've done so many damn X-Forces. I did 2 today that weren't even production videos for the public to see. What we've got here, and what I mean by that is I do a lot of stuff. Everything gets a video shot of it, but most of it doesn't actually end up to where you, the viewer, can take a look at it. Got ourselves a Fat Boy 16 pill here, and he's having all kinds of problems with it. So he asked me to take a quick look at it, make sure everything was right and actually working. We've had several transistor replacements throughout here. This transistor's obviously been replaced, and this one here, and that one here, and so on. But we've got a completely chooched out combiner ring, so I got to figure out what's going on with what, where, and how. We'll get there. So this is just the intro. He wants me to make it as reliable and bulletproof as I can. He's just using this as something to fill his hobby time with. So we're going to go in here and we're going to overhaul a bunch of stuff, like this stuff here. I'm going to change all of this. So, and then we don't have evenly matched fans. That's got to be a tight fit. Fans significantly thicker than the rest of them. So anyhow, we're going to take this thing apart. We're going to replace and hook up the relay so it's all on there right and make it so it's good again. Gentlemen, give me a minute. This kind of trick, they've got these 2 little leads that come out here. They run over here and they go to this LED. And the LED is actually acting, because it's a light emitting diode, it's actually acting as the clamp diode for the keying circuit. But so we went in and we got rid of this. Where'd it go? No, I lost it. Here it is. Went in and we got rid of this and pulled this horse manure out and replaced it with this shiny pretty thing. So now it's got a good solid ground. Took a piece of 1/0 gauge, hooked it up. Now we're running at like 14 volts. I'm putting about 100 watts in this thing. And I'm sitting here and I'm watching all the transistors. They're all heating up. You can see them with the flare. They get bright. They say, we're working. Hey, Dad, we're working. We have got a serious imbalance going on because these output resistors are all getting red. Okay, so, well, these 2 are getting red. These 2 are not, but I have a feeling that this output network, these capacitors here are being a little pain in the butts. Let's go ahead and let's run it up here real quick. It's on a 2,000 watt scale and peak with 100 watts, about 80 watts of drive. Oh, it's about 1,200 watts output. Should do a whole lot more than that. So now that we know that we're not going to be in here pulling a bunch of transistors out, and we're not going to have to do any of that malarkey, this is basically a cleanup and rework. That's all this is going to be. Thank God. So give me a hot minute. Oh yeah, the other thing is I took up my punch and I knocked the corners of these down. For some reason the front edge of this cabinet was bent back and up, so it had a very distinct bow to it. But as you can see, this thing's been bent before. So what we're going to do now at this minute is I'm going to disconnect all of this and we're going to go give it a bath. We're going to give it a bath and we're going to see if we can get all the flux and the garbage and stuff like this kind of thing all cleaned away from the transistors. See if we can make it all look pretty. We're going to do the power wire upgrade and we're going to check all the caps, remount the relay, and see if we can get our imbalance to go away. Give me a minute. Okay. It's literally been 3 days since I shot the last segment that you guys watched. In that 3 days, I've had a lot of stuff going on. I've got a really sick elderly family member is what's going on, you guys, and I've been spending a lot of time dealing with that and learning about healthcare, and a lot of time dealing with that. And then I spent this whole last weekend with my kid, which was amazing. My 12-year-old daughter. Mama went out of town, so while she was out of town, I got to pretend like I was Disney dad. And boy, did we had a good time. We went and did a whole bunch of fun stuff. But so here it is Monday evening, and I'm back out here working. See, when we left you last, this thing was all torn apart, and it needed a bath. That's where I was. Needed a bath, and the relay was hanging loose, and we just tested the thing to prove that it actually worked and all the transistors worked. We'd pulled this thing out of there, which was what was serving as the ground. So, scary. Upgraded the ground. I gave them all new power wires because the power wires that were in there were very beat up. And it's like he had an eyelet screwed to another eyelet or an eyelet with a bolt to another eyelet to make it about this much longer. So I just went ahead and replaced everything. Put all brand new Stinger cable in here. Then went in and redid all the power distribution on this thing. Then we got rid of all these burned up little 100 ohmers that were in here. And got rid of all these little burned up 100 ohmers. And replaced them with nice big brand new flame resistant 5 waters. Redid our distribution, obviously, but what our problem was is that one of the circuits had come unbalanced. And so this, let's see if I can remember which one it was. That's a 1000 puff cap, and then I think the one that's burnt, that one there. Do you need a burnt? Okay, right there. Its value, instead of being 150, is I think about 10. So what we did is we went in and replaced the output tuning capacitors for each section. So that got rid of the imbalance over here in the output network. And then I changed the output coil to a little bit bigger, higher turns, and dialed it in just a little bit more. Now, I'm just sitting here playing with it. We're playing with it because the next thing I got to go do is the fans. The fans are very worn out and they need love. And I'm going to replace all 4 of them, put new fan guards in there, and we're going to put high flow fans in this thing to give it a prayer of lasting. So, let me show you what we're doing here. Let me grab the microphone for the derail radio. It's a 1000 watt slug in 5X, so it's reading 5000 watts. So we're reading at middle scale at a 0. 5000 watt slug in average, and a 5 watt slug back from the bird, 10,000 watt dummy load. So we're going to put about 500 peak watts of drive in this thing. About 200 watts average. On 14 volts. Make a nice 3,500 peak watts. 17 and some change average. That's hitting it with a 2-pill. Give me a second. Okay. So now we brought in the line. We've got the 2-pill, driving a 4-pill, driving a 16. So I'm going to go ahead and shut the 16-pill off. Grab the mic for the derail radio. About 1100 watts of peak power. Right at 500 bird. Let's turn this back on. Oh, and I repaired your transmit light, by the way. That resistor was all broke off and broken. 2000 bird. Now, in all fairness, where we're metering the voltage from is the case and right off the board. So watch the voltage drop on the inside of the amplifier. Okay. Just had a big long conversation with Derail's brother down there this evening. We were talking about capacitors. talking about capacitors, and the other thing we're talking about is how much guys don't get that they're giving up in their system and their system's ability to be able to work by bad solder joints, bad eyelets, mechanical connections versus a physical electrical connection. There's so much voltage loss at each one of those connections. Like, I'm losing a bunch of current by having the wire just smashed underneath that ring like that. But there's no other universal way to do it unless I get all of you guys to be talked into using the exact same connectors. That ain't gonna happen. So let's go ahead, we're gonna pump the voltage up. We're gonna come up to 16.3, but that doesn't matter for much because we're metering the voltage on the inside of the amp, so we can only take the watt reading of what the voltage actually dives to. And it's 16.3 volts to that connection, but because that connection's so poor, underneath an amp load, we're going to see our voltage drop down to about 14 volts. So check it out. 14.3. 4,500 watts. 2,300 bird. That's the beauty of having that supercapacitor in line, is that it helps take up a lot of the little tiny electrical losses. And now we're talking, we brought the voltage up a whole volt internally in the box, and we've seen another 500-600 watts come out of the amplifier, and we didn't change anything else in the circuit just by dialing the voltage up a little bit. And really where we're having our loss is right there at that crappy connection. So if I was to hydraulically crimp and solder on an eyelet and then use a bolt at that connection, we wouldn't need to crank the voltage up so high. Just saying. But then again, we wouldn't have the voltage drop taking place on the inside of the amplifier. Okay, now this thing is done, tested and done. The last little bit I got to do is clean this up. Now, there's really nothing wrong here. Looking at it from the outside. But on the inside, we got a bunch of different fans. Not any of the blocking's the same, and there's a whole bunch of splices in it. So I'm probably just going to say to piss on it. We're going to take all this shit out, and we're going to get the exact same size of fan. That way everything's got uniform pressure on it, but we're going to go with some high flow fans. Alright, let me get all this shit cleaned up and make it so we just got the amp here on the bench. Give me just a minute. It's gross. Look at this. It's dirty. It's so gross. It's alright, we're going to clean it all up. Now, I got to tell you, when I washed this thing, I forgot to mention this. The Fat Boy logo washed off. I mean, if you squint and you hold your tongue just right, you can see it, but it's okay. We're going to put a brand new sticker on there. Don't worry none about it. Give me a second. Let me get this tin all cleaned up. 4 new fans. 4 new fan guards. And I took the time and I scraped all the poop. All the brown poop off the top. Lots of acetone, lots of window cleaner. Got her cleaned up. So let's put the lid on it. And before I do that, I want to say that I did have to go through and pim nut several of these because the pim nuts were either broke, knocked out, or stripped out. And then I had a couple that I had to thread chase. So you're all back up and running as far as that's concerned. So let's put the lid on. So this is my SIG Kilo. The 2400 ABS. This is the shit right now that's being produced by SIG. This is my rangefinder. My stand for my rangefinder. I got this as a thank you gift from a friend of mine. And this is the wind meter for my Kilo. I was twiddly dinking around with this the other day, and it made me have an idea. The idea that I got from the Kilo was this guy. This is the cheapest, literally, the cheapest wind gauge that they sell on Amazon. But man, this thing is accurate. The only thing I haven't figured, and I've only played with this for like 5 minutes. The only thing I have not figured out is how to change this from Celsius to Fahrenheit. That's okay. We can all do 30, right? Or whatever it is, the conversion. Do some simple math. Okay, so look. I didn't have this when I started. This showed up like 2 days ago. Otherwise, I would have shown you the CFM difference between the fans that I have here that are in it now versus what was in it, which are these dirty old Evercools. Okay. So let's go ahead and let's turn this on for a minute. Now right now we're set at miles per hour. So we're getting 3.8, 4 miles per hour intake per fan. So now let's go over here and let's look at our exhaust airspeed. 9.9 miles per hour. Let's take and change our unit of measure. So let's see. That's knots. So we get 4 knots of air in. 7.4 knots out. Now let's look at CFM flow. It's cubic feet per minute. So now the rough air intake for this is 400. $270. About 270, 280 CFM in. $700, and we'll say 69 on the output. This thing is slick. I dig it. Yeah, it's all done, man. What's going on here? Oh, we're working. We're not working. So now it's working. It's turning in the right direction. It's spinning down on its own. Fan's working. I think we might have reached the point of cavitation here. Too much back pressure. Dude, we're moving a ton of air through this box. A ton. And that's important, because I know that you're going to just stand on this thing and run the crap out of it. Well, Mr. J, you're all done, buddy. It's been a long process and a long road. Even though it wasn't that big of a repair, all we really did was power wires, clean it up, retune it, and replace a few parts. I think the bad ground did you more damage than anything else. And I can tell you right now that some other fuzzle nuts has been in this thing with their fingers all up in it. And that's the reason that this thing ended up having problems. This isn't the way it came from Fat Boy at all. Trust me, I know them guys, and they can build. Look, guys, my name is BBI. And it's been a long day. It's like 2 a.m. in the morning, and I still got to edit the video together for this thing. I got a lot going on over here. I appreciate everybody's patience with all the different projects. I appreciate everybody just letting me work at my pace, and I want to say thanks to everybody. I'm just trying to get things done as fast as I can, and this one's been on the bench for a couple days and just had to get finished. So On that note, I'm out of here. It came in here doing 2,300 watts, and it's leaving out of here doing 4,800 PEP and 2,300 bird with 500 bird drive. That's right. By anybody means of the book. That's right. Guys, I gotta go. I appreciate y'all's support, and if this is the first time you've ever watched one of my crazy videos, man, click subscribe. Click like if you enjoyed what you've seen. And trust me, guys, we're going to spend a little bit more time playing with this thing. I'll see you guys. Bump, bump from the biggest duck in Idaho. Bye-bye.